Logarithmic equations are equations that contain logarithms. Doesn't matter what type of logarithm, it's going to depend on the base of the logarithm that is in the equation. But if there is a logarithm in an equation, it's called a logarithmic equation. The key to solving a logarithmic equation is to exponentiate in the case of a natural logarithm or any base for that matter. So exponentiate when we have a natural logarithm simply means raising it to the power of e. So to exponentiate simply implies raising to the power of e when we have natural logarithms. So, but prior to exponentiating, we've got to make sure that natural logarithm is by itself, so that we can use the property that e raised ln of whatever function that we have would simply be equal to that function. So there are two ways to solve the first problem here. The first approach is to divide by 2 on both sides. So we have ln of x equals 4 over 2, which would mean ln of x is equal to 2. Exponentiate on both sides. E raised ln of x would be equal to e raised 2. The natural logarithm and ln would go away, and we have x is equal to e squared. And e squared we can easily find using the calculator as 7.39 approximately. Or we could say 3891 if we want more decimals. That's one way of doing it. Another approach is to use the properties of logarithm to recall. We have m log x is simply log x raised m. That is standard power rule of logarithms. So when we have natural logarithm or 2 ln of x equals 4, I could write it as ln of x squared equals 4, which would simply imply x squared is equal to have to exponentiate on both sides now. E raised ln of x squared would be equal to e raised 4. The e and the ln would go away, so we have x squared is equal to e raised 4. This would imply x is equal to square root of e raised 4, which is simply e squared. Now one may ask, well, when we take the square root, the answer has to be plus or minus 2, and why do we have it at plus to positive 2 and not looking at negative value? The reason for that here is that we can't have a negative value in logarithms. The domain of logarithms start at 0 and go all the way up to infinity. So we can't have a negative value, which is why we retain the positive value of square root of e raised 4, which is e squared. So here, before exponentiating, we've got to isolate natural logarithm by itself, or else we cannot cancel the exponent and the logarithm. So the first step is to move 6 to the other side. So we have 8 minus 6, which would give us 2. So 3 ln of x would equal to 2, which would imply ln of x is equal to 2 over 3. We have natural logarithm by itself, and that is equal to 2 over 3. So exponentiate on both sides, e raised ln of x would equal to e raised 2 over 3. The exponent and the logarithm would get cancelled. So x would equal to e raised 2 over 3, which we can evaluate using the calculator. 2 over 3, 1.95. Or we could write it as 1.948. The more decimals we have, the better it is. In this example, we have two logarithms combined, and we've got to recognize that we need a natural logarithm by itself on the left-hand side for us to exponentiate on both sides and solve the equation. So the first thing to do here is to recollect or recall the product rule for logarithms. Ln of x plus ln of y is equal to ln of x times y. So here we have ln of x multiplied by ln of x plus 2. So we have ln of x times x plus 2, and that would equal to 0. So now that we have isolated ln by itself, we would have the ability to exponentiate on both sides. So e raised ln of x times x plus 2 would equal to e raised 0. The exponent and ln would get cancelled. So x times x plus 2 would equal to 1, which would imply x squared plus 2x would equal to 1, which would imply x squared plus 2x minus 1 would equal to 0. Now that is a quadratic equation, and we want to find the root of the quadratic equation, so we can use the quadratic formula. So minus b plus or minus square root of b squared, 2 squared, minus 4 times a times c divided by 2a. Minus 2 plus or minus square root of 4 plus 4 divided by 2. So minus 2 plus or minus square root of 8 over 2, which is minus 2 plus or minus square root of 8 is simply 2 root 2. And we have a 2 in common. If we cancel it out, we have minus 1 minus root 2 and minus 1 plus root 2 as the two possible solutions. But we've got to keep in mind that for that equation to be satisfied, we cannot put a negative number in the logarithm. So out of the two, only negative 1 plus root 2 is a valid solution, because that solution is greater than 0 and that solution is less than 0, and I cannot plug in a number less than 0 for ln of x and expect the solution to be equal to 0. That's not feasible. So the solution here is -1 plus square root of 2. Here we have a numerical problem where we are trying to solve the equation so that 400 times 1.06 raised t is equal to 1300. So the power here is t. We have to take the natural logarithm on both sides first. So, before we do that, we can divide by 400 on both sides. So 1.06 raised t is equal to 1300 divided by 400, which is 13 over 4. But if you look at this equation carefully, this is not a logarithmic equation. This is actually an exponential equation. And typically we can solve it by taking the natural logarithm on both sides. So if we take natural logarithm on both sides, we end up having ln of 1.06 raised t is equal to ln of 13 over 4. If we use the properties of logarithm, we can move the t to the front of the natural logarithm. So t times ln of 1.06 would be equal to ln of 13 over 4, which would simply mean t is equal to ln of 13 over 4 divided by ln of 1.06. So in your calculator, ln of 13 over 4 divided by ln of 1.06 would give you 20.2278, which I could approximate it as 20.228. This is a problem similar to the previous one, and we could actually solve or simplify the term that is inside the power prior to finding the solution to t. Again, note that this is an exponential equation. So in order to solve it, we don't exponentiate, we take logarithm on both sides. But I'm going to simplify the term that is inside the parentheses. So 0.07 divided by 12, I get 1.0058 repeating. I'll call it 1.006 raised 12t equals 3. And that reduces to the problem that we had previously. And the same approach can be used. So take natural logarithm on both sides. And one can view that equation as a logarithmic equation. So using the power rule of logarithms, the 12t is going to come to the front. 12t multiplied by 1.006 equals ln of 3. 12t would be equal to ln of 3 divided by ln of 1.006. Which would mean 12t is equal to 183.65. Divide by 12 on both sides, so 183.65 divided by 12 would equal to 15.304. So here is an application problem where the population, P in thousands, of Charlotte, North Carolina from 1980 through 2013 can be modeled by this expression, which is P equals 321 e raised 0.0275 t. And t equals 0 corresponds to time or year 1980. So we want to find the population in the year 2013. 2013 happens 33 years from 1980. So t equals 33 would imply the year 2013. That said, we want to find the population of Charlotte in the year 2013. So the population would simply be 321 e raised 0.0275 multiplied by 33. And we can evaluate that using the calculator. And that happens to be 348.61 approximately, and that is in thousands. So we end up getting 348.61. Now we want to know in what year will the population of Charlotte would reach 1 million. So first thing to do is to convert that 1 million to thousands. So we want it in thousands because the problem is modeled as P equals something in thousands. So the question here wants to know the population for a given time, T, such that the population is 1 million, which is simply 100,000, 1,000 thousands. So we can set 1,000 equals 321 e raised 0.025275 t. Divide by 321 on both sides. 1,000 divided by 321 equals e raised 0.0275 t. And that would give us 3.115. And note that that is an exponential equation. And we have to take the natural logarithm on both sides to solve. So ln of 3.115 would be equal to ln e raised 0.0275t. The ln and the e would go away, so we will have ln of 3.115 equals 0.0275t, which would imply t is equal to ln of 3.115 divided by 0.0275. And we get 41.32. If I round up to the next year, I could say 42, or if I want to round it to the nearest integer, I'm going to round it to 41, and 41 is 8 years from 2013, so the year would be 2021. When the population is 1 million. Oops. So this problem contains a logarithmic equation, not an exponential equation. As you can see, the logarithmic equation that's given to us is s is equal to 80 minus ln of t plus 1, where t is defined between 0 and 12. So students were given an exam in mathematics, and they were retested monthly with the same or equivalent exams. The score is on a 10-point scale for the class, and it can be modeled by that equation where t is the time in months. We want to know the average score on the original exam. The original exam in the sense the exam when we first the average score when we first administered the exam, that would correspond to the average score at time t equals 0. So we have s is equal to 80 minus 14 ln of 0 plus 1, which would be 80 minus 14 ln of 1, but we know ln of 1 is 0, so we have 80 minus 0, so the score is 80. We would like to know what happens after 4 months. In other words, when t equals 4, we need to know what the score would be. So s would equal to 80 minus 14 ln of 4 plus 1, which is 5. 80 minus, we can evaluate this directly using the calculator. 80 minus 14 ln of 5, which gives us 57.47. So the score decreases after 4 months to 57.47. In part C, we want to find the number of months it would take for the score to become 46. In other words, we are given the score 46, and we have to find t, the time. So 46 would equal to 80 minus 14 ln of t plus 1, and that is a logarithmic equation. So the first step is to move all the numbers to one side so that we isolate the logarithm. So 46 minus 80 would equal to minus 14 ln of t plus 1. 46 minus 80 is negative 34. The negatives will get cancelled and we can divide by 14 on both sides. So 34 over 14 would equal to ln of t plus 1. This would mean ln of t plus 1 is 17 over 7. Since that is a logarithmic equation, we can exponentiate on both sides. E raised ln of t plus 1 equals e raised 17 over 7. The e and the ln would get cancelled. So we have t plus 1 equals e raised 17 over 7. So t would be e raised 17 over 7 first. And subtract 1. The answer is 10.343. So it takes about 10.343 months for the score to decrease to 46 from 80. The key thing to remember here is that if we want to exponentiate a logarithmic equation, the ln has to be by itself on the left-hand side. And you can achieve this by simplifying algebraically or using one of the properties of logarithms. And once this is done, we can exponentiate and solve a logarithmic equation.